Hello, 8th graders. We have our third and final lesson in our second chapter for science. We're going to be looking at energy transformations and conservation. So first, let's read about a field trip titled Science Day at the Amusement Park. During Science Days at Great America Amusement Park in Santa Clara, California, the park becomes a giant laboratory. Here is how one investigation might work. You choose a ride, like the drop tower, which drops you 68 meters in less than 4 seconds. Or the firefall, which contains a series of vertical twists and turns. You observe how your speed and height change during the ride. Then you use your observations to learn about transformations between potential and kinetic energy. So how do you think energy is transformed in the drop tower? Well, potential energy is at the top of the ride because they're not moving, and it becomes kinetic energy at the bottom of the ride because they have picked up speed. So we have two key questions for our lesson today. First, how are different forms of energy related? And second, what is the law of conservation of energy? So last chapter we talked about the law of conservation of mass. Now we're talking about the law of conservation of energy. So we are looking first at our answer to our key question. All forms of energy can be transformed into other forms of energy. So what is an energy transformation? Pretty obviously a change from one form of energy to another. We have single transformations, where a toaster transforms electrical energy to thermal energy in order to toast your bread. Or we have multiple transformations. For example, in a car engine, a series of energy conversions occurs. We have electrical energy, which produces a spark. Thermal energy of the spark releases chemical energy in the fuel. The chemical energy in the fuel originated with nuclear reactions within the sun that reached Earth as electromagnetic energy. Plants transform the energy in sunlight into chemical energy, which was stored in the fossilized remains of living organisms that made up the fuel. As the fuel burns, it expands as it is broken down into smaller particles. The expansion of the fuel produces pressure on parts of the car. The increased pressure eventually causes the wheels to turn, transforming chemical energy into mechanical energy. Now, if you're like me, that was a lot. But let's count how many different conversions we had of energy. So we started with electrical energy, which then started a spark, which was thermal energy. So that's one conversion. The thermal energy of the spark releases chemical energy. That's two. The chemical energy in the fuel originated with nuclear reactions that reached the Earth as electromagnetic energy. So kind of a change. That's three. And then finally, we go down to the bottom. Electromagnetic energy. Plants transform that energy into chemical energy, 4. And then we go down here, finding out chemical energy was then transformed into mechanical energy. So 5 different transformations just in this one really quick, simple thing that happens all the time. Okay? So kinetic and potential energy transformations are the most common. For example, if you stretch a rubber band, it's elastic potential energy. If you let it go and it flies across the room, it then is transformed into kinetic energy. If you have a falling object, the height of the ball decreases, it loses potential energy, but its speed increases, which makes its kinetic energy increase. A pendulum swings back and forth. When it's at its highest point, it has no movement, but has gravitational potential energy. At the bottom of the swing, it has kinetic energy. And finally, we have a pole vault, kinetic to elastic potential. You're running, and then the pole is going to bend so that you can be vaulted over. Then you have gravitational potential energy because it's pulling you to the ground. And then finally, you have kinetic as you're falling. What about the law of conservation of energy? First of all, what is it? When one form of energy is transformed to another, no energy is lost in the process. So according to the law of conservation of energy, energy cannot be created or destroyed, just like the conservation of mass. So the total amount of energy stays the same, it just may take the form of kinetic or potential. So we have our vocabulary words: energy transformation, a change from one form of energy to another, and then law of conservation of energy, When one form of energy is transformed to another, no energy is lost in the process. All right. For your assignment, we're actually going to work on an IXL scale that takes you through a roller coaster, which shows the different energy forms in there for an example. Okay, so while it loads, we're just going to answer one question because you only have 9 to answer. So I'm just going to kind of show you what it looks like as you'll go through it. So the challenge is to answer 7 out of 9 questions correctly. So it tells you there are many types of energy. One type is kinetic, which is the energy an object has when it is moving. Read the passage about the start of a roller coaster ride and think about the kinetic energy of the roller coaster train. So at an amusement park, a group of riders boarded a roller coaster train and sat down. Once everyone was safely in their seats, the ride operator flipped a switch and electricity flowed to a motor below the track. The motor pulled the train forward and out of the station. The question asks us, which of the following is better evidence that the train's kinetic energy changed? The train was stopped and then it began to move forward and away from the station, or electricity started flowing to the motor when the ride operator flipped the switch. Okay, so that's all you're going to do. There's 9 questions. You have to get 7 out of 9 for the challenge, but just do your best. If you have any questions, as always, let me know.